Okay, so good day to all of you. So in this video tutorial, you're going to learn how to do the page replacement algorithms manually. So I'm going to show you the three most commonly implemented page replacement algorithms. So we have the first in, first out, or the FIFO page replacement algorithm. We have the optimal page replacement algorithm, and last but not the least is we have the least recently used, or LRU page replacement algorithm. So let's start with the first in, first out, or FIFO page replacement algorithm. So this is our example. So the reference string here that is indicated is the one that is also used in chapter 10, virtual memory, just to show that of course in the presentation it is already indicated the results. So how does the results have come to that which is 15 page faults? Okay, so let's start. So in our example, so we have 3 frames. So for first in, first out, what you're going to think about is not the reference string, but rather the oldest value which is inserted or being placed in these page frames. So, okay, so our first value here is we have 7. So for our first iteration, so let's just copy 7 to frame number 1. And then next is we have next is 0. So on the next iteration we have 7, 0, and then next is we have 1. So again in the third frame, so the value of the page frames after the third iteration is 701. Okay, next is we have 2. So 2 is not yet in the page frame, so 701 is the value. So we have to replace for FIFO the first value that has entered in the page frame. So since, as you can see, so 701, so the first value that entered the page frame is 7. So you have to replace 7 with 2. So write 2, and then just copy the value for page frame number 2 and 3. We have 2, 0, 1. Okay, next. And if you don't want to be confused, let's just put a marking for 2, meaning this is the latest value that has changed. Okay, next is we have 0. So since 0 is already inside the page frame, so we're going to skip on that since it is already in here. So next is we have 3. So as you can see, 2 is the latest value, meaning the next frame will be the one to be replaced. So we have 3. Okay, so replace 0 with 3, and then copy 2 and 1. And then you can put a mark on 3, meaning that is the latest value. Okay, next is we have 0. So 0 is not in this values 2, 3, 1. So what you're going to do again is you're going to replace. So the oldest value here now is we have 1. So replace 1 with 0, and then copy 2 and 3. Okay, next is we have 4. So again, 4 is not in any of the page frames. So we're going to replace the oldest again. So we have 0 here as the latest value. So what number or value we're going to replace is we have frame number 1, which is the value is 2. So copy 4 and then replace 2 with 4, and then copy 3 and 0. Then again, let's just put a mark for 4 for it is the latest value. Okay, next is we have 2. So again, 430 is the value of the page frame. Since it's not there, we're going to replace the oldest value, which is we have 3. So replace 3 with 2, and then copy 4 and 0. Okay, and then again put a mark so that you will know that it's the latest value. Okay, next again is we have 3. Again, it's not in any of the page frames. So let's replace the oldest value here is 0. So replace 0 with 3 and then copy 4 and 2 and then put a mark here. For 3 is the latest value. Okay, next is we have 0. So 0 again, it's not in any of the page frames. So since 3 is the latest, so we're going to return again, which is frame number 3, which we're going to return again to page frame number 1, and then replace 4 with 0, and then copy 2 and 3. So let's just put again a mark on 0, for it is the latest value. Okay, we already have 3, we already have 2. Okay, next is we have, let's just keep 3 and 2, and then let's have 1. So 1, it's not in any of the page frame. So the next victim frame would be, we have 2. So replace 2 with 1 and then copy 0 and 3. Again, this is our latest value. Then next is 2. It's not also in any of the page frames. So our next victim frame is we have 3. So replace 3 with 2. Then copy 0 and 1. And then next is we have 0 is already in here. 1 is already in here also. So let's just skip. Next is we have 7. So 7 is not in any of the page frame. So again, let's mark 2 as the latest page frame that is updated. So next is we have 7. So among this 3 frames, so we're already finished with frame number 3. We're going to return again to frame number 1. So replace 0 with 7 and then copy 1, 2. And then this is the latest value. And then next is we have 0. Again, it's not in any of the page frames. So select the next victim, which is 1. So 1, replace 1 with 0 and then copy 7 and 2. And then last but not the least is we have 1, since again it's not in the any of the page frames. So replace 2 with 1 and then copy 7, 0. So this is our page replacement algorithm results for FIFO. So how are we going to know how many page faults? So let's just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So with this example, we have 15 page faults. Okay, so actually there is a shortcut for this one. So I'm also going to teach you the shortcut. So let's have the shortcut. Okay, so again we have 3 frames. So let's just have a numbers 1, 2, and 3. Okay, so let's have again our reference string. So first is we have 7. So let's just mark it, meaning that you've already put it inside the page, in any of the page frame, the page frame number 1. And then next is we have 0. Okay, next is we have 1. Okay, again 2 is not in any of the page frame. So replace the oldest value, which is 7. So let's just put a strike through here, a line, and then replace it with 2. And then next is we already have 0 here. So next is we have 3. So our oldest value here, since 2 is already on the second level, so 0 and 1, which of them is the oldest? Actually, the 0. So you're going to replace 0 with 3. Okay, next is we have again 0. So since 1 is only on the first level, so since this is the only one not yet being, it's not cancelled or being replaced, so 1 will be replaced by 0. Okay, so we already have that. Okay, next is we have 4. So 4 is not here in our any of the page frames. So 230, which of them is the oldest? Actually, just like with first come, first in, first out, is we're going to put it in the which is the oldest, which is 2. So replace it with 4. And then next is we have 2. So the oldest here, of course, is 3. So replace 3 with 2. Okay. And then next is we have 3. So replace 0 with 3. Okay. Next is we have 0. So 4, 2, 3. The oldest is 4. Replace it with 0. And then 3 is already there. 2 is already also here in the page frame. So next is we have 1. So 1. So from 230, the oldest frame here is 2. So we have to replace it with 1. And then again 2. So replace 3 with 2. And then next is we have 0. So 0 is already inside the page in any of the page frames. And then we also have 1. And then next is we have 7. So 0, 1, 2. The oldest one here, of course, is 0. So replace it with 7. And then next is we have 0. So from here, 1 to 7. 1 is the oldest. So replace it with 0. And then last but not the least is we have 1. So the oldest here is 2. And then replace it by 1. Okay, so how many page faults? Actually, you can already also determine the number of page faults here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's just the same with the long method. It also has 15 page faults. So, what are you going to use? Actually, if the question is only for a reference string, then how many page faults will be produced? You can already use the shortcut. But if the question, for example, is from the reference string, if we're going to insert these 2 in the page frame, what will be the content, the current content of the 3 page frames? So for shortcut, you cannot determine at that exact time which of them, which is the current content of that page frame. So again, the shortcut will be useful if the question is just how many page faults will be produced if you're going to use, for example, first in, first out with this reference string. But if the question, the nature of the question is from the reference string, and then the question wants to know the current value of the page frames in terms of the value that is entered, so you have to go through the long method. So this is for first in, first out. Okay. Next is we have the optimal algorithm. So optimal algorithm, as the word itself, it produces the lowest number of page faults. So how does optimal algorithm works? Optimal algorithm works is the victim frame or the victim page frames, you're going to choose which of the values will not be used for the longest period of time. Okay? So again, we have this reference again, just the same with the first in, first out, just to compare if it's really true that optimal is better than first in, first out. So again, the long method is we have 7. So let's, again, 3 page frames. So we have 7. And then next is 0. So copy 7 and then 0. And then we have 1. So 7, 0, 1. So all of the page frames has already have their own values. Okay, next is we have 2. Since 2 is not in any of the page frames, so the current content of the frame is 701. So for optimal, you're going to look, it's like going to the future. Okay, so let's look where does the next 7 will be in the reference string. It's in here. Then 0, actually, so let's 0 is just right after 2. And then we have 1, which is this one. So for the 3 values, which of them will not be used for the longest period of time. Actually, it will be 7. So you're going to replace 7 with 2. And then copy 0 and 1. Okay, next is we have, since 0 is already in here, so let's just skip. And then next is we have 3. So 3 again. We're going to look again of the values of the page frames. 2, 0, 1. So in reference to 3, so do not include the past values. So we have 2, 0, and 1. So which of them has, which of the values will not be used for the longest period of time? So we have 1. So you're going to replace 1 with 3. So replace 1 with 3 and just copy 2 and 0. Okay, next is 0 is already in here. Okay, next is we have 4. So let's skip 0. So 4. So our the current content of the page frame is 2, 0, and 3. Okay, 2, 0, 3. So we're already in 4. Okay, 2, 0, 3. Which of them will not be used for the longest period of time? It is 0. So replace 0 with 4. Okay, and then copy 2 and 3. Okay, next, we already have 2 inside in the page frames, and then 3 is also already there. So next again is we have 0. So 0, the current value is 2, 4, 3. Let's look again. 2 and then 4. Actually, if you can see, 4 will not be used anymore, will not be referenced. And then 3 will just be right after 0. So since 4 will not be used anymore, so you can replace 4 with 0. Okay. And then just copy 2 and 3. Okay, next. 3 is already in here. 2 is also in here. So next is we have 1. So our current value now is 203. So in reference to 1, so 2, 0, since 3 is already not referenced here in the string, so replace 3 with 1 and then just copy 2 and 0. So 2 is already in here, 0 is already also in here, so 1 is also in here. So next is we have 7. So we have 2, 0, 1. So the only values left is we have 0 and 1. So since 2 will not be used, so this will be replaced. 2 will be replaced by 7 and just copy 0, 1. And then 0 and 1 here is already inside in any of the page frame. Okay. So again, to determine how many page faults is produced by using the optimal page replacement algorithm is we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So total we have 9 page faults. So we have 9 page faults. Okay, you can also apply the shortcut method here. So shortcut method. Okay, so our shortcut method again, so we have 3 frames. Okay, so we have 7, 0, 1. So let's just check. Okay, next is we have 2. So 2, the content is 7, 0, 1. Which of them will not be used for the longest period of time? So we have 7. So 0 will be next, and then 1. It's just between 0 and 7. So replace 7 with 2. Okay, next is we already have 0. Next is we have 3. So our current contents of our page frame is 201. So already in 3. So 201. So since 1 will not be used in the for the longest period of time compared with 0 and 2, replace 1 with 3. Okay, let's replace 1 with 3. So we already have 0 there. Next is we have 4. So 4 is not yet in any of the page frame. So the current value of the page frames is 203. So 203. So which of them will not be used for the longest period of time? It is 0. So replace 0 with 4. Okay, so we already have 2. We already have 3. Okay, next is we have 0. So if we have 0 here, and then our value is 243. We have 2, 4. 4 will not be used anymore, and then 3 will just be used right after 0. So since 4 will not be used, replace 4 with 0. And then next, 3 is already there. 2 is also already there. So next is we have 1. So 1, let's look. The value is 203. 20, so 3 is not referenced anymore. So since it will not be used, replace 3 with 1. Okay. Then next is we have 2 is already in the page frame, 0 it's already also there, and then we have 1. Okay, next is we have 7. So 0, 1 will the only values that are left. So since 201 is the current value and 2 will not be used anymore, so replace 2 with 7, and then we have 0, and then we have 1. So again, to know the number of page faults, just count all the values, including the with the one with strike through lines, 1, 2, 3, 4, 5, 6, 7, 8, 9. So just the same, 9 page faults. Okay, so this is our optimal page replacement algorithm. So better than the first in, first out, which has 15 page faults. So next is we have, last but not the least, we have the least recently used. So least recently used is the opposite of optimal algorithm. So it looks on the past value. So its idea is maybe the past values will be used again. That is the implementation of least recently used. Okay, we're going to use again the same sequence which is presented in the slideshow. So again I'm going to do the long method. So we have 3 frames again. So we have 7, and then next is we have 0, 7, 0, and then next is we have 7, 0, 1. Okay, next is we have 2. Okay, least recently used. So in reference to 2, we're going to look on the past values. Which of them is least recently used? Okay, since 1, this is the most recently used, and then next is 0, and then next is 7, since our value 7, 0, 1. So we'll replace 7 with 2. So replace 7 with 2 and just copy 0 and 1. Okay, we already have 0 in here, so let's just skip 0. So next is we have 3. So our values here is 2, 0, 1. So 2, 0, 1, which of the 3 values here is least recently used? 2, 0, 1. Since 1 is the least recently used, replace 1 with 3 and then copy 2, 0. Okay, next is 0 is also already in the page frame, number 2. So let's just skip it. So next is we have 4. So 4 is not inside in any of the page frame. So okay, so the current values of the page frame is 2, 0, 3. We have 2, 0, and 3. Okay, for this one, we're going always to reference on the most recently used. For example, for this one, we have 2 zeros here. You're always going to reference your values with the most recently used value. So 2, 0, 3. Which of them is the least recently used? So we have 2. So we have to replace 2 with 4 and just copy 0 and 3. Okay, next is we have 2. Okay, 2 is not inside in any of the page frame. So again, the current value is 403. So 3 here is the least recently used. Replace 3 with 2 and just copy the values of 4 and 0. Okay, next is we have 3. So it's not again inside in any of the page frame. So our current value here is 402. Since 0 here is the least recently used, replace 0 with 3 and just copy 4 and 2. Okay, next is we have 0. So 0 is also not in any of the page frame. So 432. 432. Since 4 here is the least recently used among the 3, so replace 4 with 0 and just copy 3 and 2. Okay, so 3 is already inside, 2 is already inside in the page frames. So next is we have 1, which is not yet included in the page frame. So 1, so our value now is 032. Since 0 is the least recently used, replace it with 1 and then just copy 3 and 2. Okay, so 2 is already inside, so let's just skip it. Next is we have 0, so 0 is not yet in the page frame again. So the value is 132. Since 3 is the least recently used, again, replace 3 with 0 and copy 1 and 2. And then next, we already have 1 in here. And then next is we have 7. 7 is not in any of the page frame. So the values, the current value is 102. 102. Since 2 is the least recently used among the 3, so replace 2 with 7. And then just copy 1 and 0. And then 0 is already here, and then 1 is already inside the page frame. So this will be our result for least recently used. Okay? So how are we going to get the page faults? Let's count the number of page frames that has changed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for this example, we have 12 page faults. Okay, so again, let's apply the shortcut. Okay, shortcut. So again, 3 page frames. Okay, so we have 7, 0, 1. Okay, next is we have 2. So let's look at the past values. So 701. So the least recently used here is 7. So replace 7 with 2. Okay, 0 is already there. Next is we have 3. So our current value is 201. So since 1 is the least recently used, replace 1 with 3. Okay. Next is we have 0. It's already in any of the page in frame number 2. Okay, next is we have 4. So 4 is not yet in here. So the current value is 203. 203. Since 2 is the least recently used, replace 2 with 4. Okay. Next is we have 2. So since 2 is been removed, 403. So 403. 3 is the least recently used. Replace 3 with 2. Okay. Next is we have 3. So again, it's removed, recently removed. So the current value is 402. 402. 0 is the least recently used. So replace 0 with 3. Okay. Next is we have 0. So 0 is removed from the page frame. So the current value is 432. So we have 432. 4 is the least recently used. Replace 4 with 0. And then 3 is already there. 2 is also in the page frame. Next is we have 1. So 1 it's not yet in the page frame. So the value is 032. 032. So this is the least recently used which is 0. So replace 0 with 1. Okay. Next is, we already have 2. Next is 0. So 0, our current value is 132. So we have 132. Since 3 is the least recently used, replace 3 with 0. Okay. Next is, we already have 1. Next is, we have 7. So our current value is 102. So 102. Since 2 is the least recently used, so replace 2 with 7. And then 0 is already in the page frame, and also 1 is already in the page frame. So we have number of page faults 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just the same, 12 page faults. So we're already finished with showing you how to do the page replacement algorithms. The question now here is, which of the following page replacement algorithms is the best in reference with our reference string? So as you can remember, so with first in, first out, okay? So for first in, first out, so we have how many page faults? So we have 15 page faults. And then for optimal page replacement algorithm is we have 9 page faults. And of course, for our least recently used is we have 12 page faults. So if we're already going to decide which of them has the best performance, or the performance is based on how many page faults that the page replacement algorithm has produced. The lower, of course, the better. So among them, so the winner for our example here is the optimal, which is 9 page faults. So LRU actually sits between, for this reference string, sits between the FIFO and the optimal. So because it's 12, and then FIFO is 15, and of course optimal is 9 page faults. So of course our answer here is the best choice for the page replacement algorithm according to the results of that is produced by the page replacement algorithm is of course the optimal, which is again 9 page faults. So I hope that you've learned something about our tutorial. So again, so I've introduced to you the shortcut method. So this is only used whenever the question is all about asking number of page faults. You can use this. But again, if the nature of the question is you're asked what is the content of the current content of the page frame when you are referencing a certain value in the reference string. So if you do have any questions, so please feel free to comment below, and don't forget to subscribe to my YouTube channel. So again, thank you very much. Good day and stay safe.